Hey guys, welcome to another video. You are doing a Nearpod today, so what we're going to do, this video format will be a little bit different. It's not notes. There will be some places where we pause and either you put notes in your journal or you take a quiz or you look at something else. So let's get started. Today, we are writing equivalent expressions with integers, and I know that sounds very kind of complicated, but what we're basically doing is rewriting our math problems so that they work for us better. So what we're going to do is we're going to take what we have learned in the past week about adding integers and extend it to subtraction. I'm going to show you what I mean by that in a second, but let's review quickly what we know, what we've learned about adding integers. We know that if we have a -4 and a -2, we can graph that on a number line by starting at 0 and then doing whatever the first number tells us to do. The first number is a -4, which means we are going to start at 0 and move in the left direction, and we're going to go down 4 spots to land at -4. But we're not done. We also have to do what the second number tells us to do, or what the next number in line tells us to do. So the next one tells us -2, which means to continue to go left. We're going to continue to go down 2 more spots. And this number line is not perfect. I sketched it out. Normally you want your numbers to be more evenly spaced. But we're going down 4 spaces and down 2 spaces. And then altogether that ends up going down 6 or ending up at the -6 spot. We also talked about integer counters. We know that here for this problem we have a +3 and a -10. We know that the positive numbers are represented by yellow plus signs. If you only have a pencil, the plus signs are fine. But you can go ahead and record what's on our board. What we have is a +3 and a -10. So we have 3 positives and 10 negatives. 2, 3, 4, 5, 6, 7, 8, 9, 10. And we also know in math and in science, a positive and negative cancel each other out. So you may have learned that a proton and an electron give a neutral charge put together. The same goes for math. A +1 and a -1 end up being 0 when put together. So we know every positive cancels out a negative. So we can cross those out. Some people circle them. Either way, that's fine. But what you're saying is each of these positives cancel out with a negative. And you have your answer, whatever's left is your answer. So we can count those 1, 2, 3, 4, 5, 6, 7. Once we have all of the 0 pairs canceled out, what we have left on our board is 7 negatives, which means our answer is -7. Our goal today is to take what we've learned and carry that over to subtraction. And the way we're going to do that is we're going to manipulate, our goal is to be able to manipulate any addition or subtraction problem with integers so that we can find the solution. Okay? So we're going to manipulate an addition problem or subtraction problem so that it fits what we know better, so that we can add and subtract those integers. Before we get going, I want to remind you of the commutative property of addition. The commutative property of addition says that you can change the order of the add-ins and the answer will be the same, okay? So it's basically, in math laws, it's legal for us in an addition problem to change the order, and it won't affect the problem. For example, 3 + 8 is 11, we know that, but we also know that 8 + 3 is 11, and therefore, changing the order of those numbers did not affect the problem. Okay, so let's get started. Knowing all of that, let's get started. So what I have here is 3 different math problems: 9 - 4, 9 + -4, and -4 + 9. So the first thing I want to talk about is the fact that these 3 problems, while they look different on paper, actually mean the same thing. We can rephrase them a little bit. They're basically like a sentence that we rephrased, but it still has the same meaning. So let's talk about the first example, 9 - 4. We have three real world examples. I know that it's kind of almost a little silly to talk about having 9 apples, but we're starting at a really basic level so that you can understand what we're talking about. So 9 minus 4 means that you have 9 apples and you give away 4, okay? And as you probably learned in earlier grades, if you start at 0 and you go up to 9 on the number line, and I know that black can be a little hard to see, you go up to 9, you to show this addition problem, I apologize. To show this subtraction problem, you can go up to 9 and then do whatever the second number says to do, and that is go down 4. So we can count however you want to do that. If you like to jump 1, 2, 3, 4, or if you just like to draw the arrow, that's fine either way. We went up 9 and now we're going down 4, and we end up with the answer of 5. So that's pretty straightforward. And what we've started doing in 7th grade is bringing the negatives into the mix. So let's look at this second problem, 9 plus negative 4 on the number line, and see how that looks. So the example is a little bit different, but we'll see that the result ends up being the same. I have 9 apples, and I also owe my neighbor 4 apples, so I have a debt of 4 apples. Again, you're starting with the first number, you're going up to 9, positive 9, that's 9 apples. And then the second number says negative 4. It's a debt of 4, it's going down 4. Either way, we owe 4 apples, and so we can come back down 4. So we go up 9 and down 4. And that ends us back up at 5. This could also have been represented with our integer counters. You could have seen that having 9 apples is like having positive 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And having 4 negatives is like having negative 4. And once we go to cancel those out, 1, 2, 3, 4, what we have left is 1, 2, 3, 4, 5 positives, or positive 5. So we've represented that numerically, physically with a model, and also with a number line model. So the last one I want to talk about is negative 4 plus 9, okay? And that one does look a little bit different on our number line. So let's talk about we owe 4 apples already, so we start off at a debt of 4 apples, but we end up getting 9 apples, okay? So let's start on our number line. If we start at 0 and we go, the first number now is negative 4. We go down to negative 4. And then our second number is positive 9. So here's what happens. We actually end up going up 9, which means we're going to cross over the 0 into the positive side. And again, you can count 1, 2, 3, 4. We know that going down 4 and then up 4 ends us back at 0. That's our additive inverse. But we're not done. We have to go up 9 in total. So we went up 4, and now we're going to go up 5, 6, 7, 8, 9. That ends us back again, once again, at positive 5. Again, you can represent this as 1, 2, 3, 4 negatives and 9 positives. 4, 5, 6. If you run out of room, just come on down. 7, 8, 9. And cross out 1, 2, 3, 4. And what you have left is 1, 2, 3, 4, 5. 5 positives. So what we're seeing here is we have 3 different problems. 9 minus 4. 9 plus negative 4. And negative 4 plus 9. Either way, on all 3 of those, we ended up with the answer of 5. Again, the 3 situations look a little bit differently, but the result is the same, okay? So let's talk about what we're doing here. What we're saying is 9 minus 4 is the same as 9 plus a negative 4, because all you're saying is you have 9 and then a debt of 4 in some way, or you're giving 4 away. And we also know earlier, because of the commutative property, here we have now, we've taken a subtraction problem and now we have an addition problem. We changed it from 9 minus 4 to 9 plus something, but that plus something is a negative 4. So we are adding a negative 4. That's the same as subtracting a 4. And we also know, because of the commutative property, we can switch these numbers around. So we can put the negative 4 first. Well, if we put the negative 4 first, what do we have with it? A positive 9. And we end up with the same result either way. I know that was a lot. Let's move on to another example and see if that kind of, it starts to make a little more sense. So here we have a different scenario. We are dealing with temperature, but let's talk about it. So our first example is 6 minus 1. The temperature is 6 degrees and it falls 1 degree. We can represent that as on the number line, moving more quickly, starting at 0. We can go up 6 and then down 1. Where we end up is 5. Okay, so we end up back at 5 again. So our answer is 5, just like the previous slide, which is kind of a coincidence. It doesn't have anything to do with the problems. So we start at 6 and we go down 5. Again, we can look at number 2, or the second example, 6 plus negative 1. On the number line, we start at 0, go up 6. And go down 1. Again, ending us up at positive 5. This situation is phrased a little bit differently. The temperature is 6 degrees, and then there's a decrease of 1 degree, but that's not much of a change. Again, ending up at positive 5. Okay, and now for the third example, we have a little bit of a different scenario where we start at 0 and we go down 1 degree. And then we rise 6 degrees. So 1, 2, 3, 4, 5, 6, or up 6. For all three of these scenarios, we end up back at a temperature of 5 degrees. So let's talk about what happened mathematically. What we have here is 6 minus 1. We know that that is 6 take away 1. 6 take away 1. We also know from our previous example, and we're going to keep practicing this is that saying 6 take away 1 is saying 6 and a negative 1. We are also saying we have a 6 and we also have a negative 1. So we can write that as an addition problem with a negative 1 instead of minus 1. It's the same thing. And again, because of the commutative property, we know we can move these guys around and we'll end up with the same answer. So if we want to put the negative 1 first, we can do that, and we're going to put plus 6. Either way, no matter what we put in any three of these expressions, they equal the same thing, which makes them equivalent expressions. So it doesn't matter if we write 6 minus 1 or 6 plus negative 1 or negative 1 plus 6. Those are equivalent expressions because they equal the same thing. Okay, so moving on to our third example. We have three situations written the 3 different ways, and let's talk about what they mean. So we have 2 minus 8. That is like having $2 and you spend $8. Okay, so we can start on the number line. Let's work on our vertical number line for a change. So let's say your bank account is here at $2. So we start at 0 and go up $2. And then when you go to spend $8, what's going to happen is you're going to spend more money than you have. So you're going to go down the 2, which is your additive inverse. So you're going to go down $2, but then you're going to have to keep going because you've spent more than what you have. So past 2, we're going to go down 1, 2, 3, 4, 5, 6. So we've gone down 8, and we can count that out. 1, 2, 3, 4, 5, 6, 7, 8. Either way, we end up here at negative $6. Okay? Let's talk about that written a little bit differently. So let's say we have a credit of $2, which means we have $2 in our account, and also a debit of $8. That means we spent $8. So it basically means the same thing as our first example, but it's saying it in a little bit of a different way. So this is a credit of $2 and a debit of $8. We can, again, represent that on a number line. I think this time what we're going to do is we're going to show up to and down 8. I'm not counting those out for you this time because you should be getting used to that and doing that on your own as we go along. Okay, so we go up to, down 8, ends us at negative 6 again. Okay, so we still have negative $6. And our last example is negative 8 plus 2. And that does give us a little bit of a different scenario, but it's basically reordering what we have. We're reordering what our debit and credit is. So this time our debit or our money we owe comes first. So we owe $8 and then we get $2. So we're dealing with the debit first, basically. So we're going to go down 8. And then we're going up 2. Either way, we ended up back at negative 6. If you are working with algebra counters, which is one of my favorite ways to do this, and it's a little hard to see on the purple, you may have written out 1, 2, 3, 4, 5, 6, 7, 8 negatives and 2 positives, and that will get you an answer of 6 negatives or negative 6. And one more time, we're going to talk about what we did mathematically here. We took 2 minus 8. We know that's having 2 and going down 8. And instead of a subtraction problem, we wrote an addition problem. The problem is here, we can't just say 2 plus 8. Now it's a totally different answer, but we can say it's 2 plus a negative 8. So we're changing the the subtraction problem to an addition problem, but we're making sure to keep the same answer by indicating that that's a negative 8. Now, one of the things that I haven't really covered yet that I want to talk about now, and I apologize for waiting this long, is when I change this to an addition problem, and then I try to throw a negative in there, it becomes a little messy with all of this going on. So whenever you see 2 signs in a row, like a plus and a minus right next to each other, or a negative and a negative right next to each other, whenever you see those symbols just right next to each other like this, in general, good mathematical practice, people will put a parentheses around it so that you know that negative goes with the 8, and it just kind of helps it keep it a little cleaner. What that does not mean is that the negative 8 you have to deal with first or anything like that about order of operations with parentheses. So the parentheses are just there to keep things clean, to keep things a little less confusing so that you don't have those signs right next to each other. And I apologize, so to go back to what we were talking about, we changed the subtraction problem to an addition problem by adding a negative instead of subtracting. And we can also rewrite that using the commutative property by putting the negative 8 first and adding 2. So we're switching the order there. Okay. This is our last one. Our last one for this section, and then we'll have some different examples, because for all of these, we are taking a positive number and we're subtracting a number or adding a negative. So basically, we have a positive and a negative that we're adding together. And in the next section, you will see some integers in different order, okay? So our last example is 3 minus 5. And this could be explained by having 3 points and losing 5. So you would go up 3, and then down 5. Remember, you're going to go, if you go down 3, that'll get you back at 0, and then you go down 2 more, that'll be 5 total that you went down, ends you up at -2. All right, so we can change this to an addition problem by saying 3 plus a 5. The problem is we can't just say plus 5 because now we have 8 points. That's different, right? But we can say we have a gain of 3 points and also a loss of 5 points. Well, a loss is a negative, so we're changing that to -5. So let's write that over here. 0, we go a gain of 3. And a loss of 5, we land at -2 again. And we know that we can also write that as plus 3 and minus or 5 negatives and cross those out, and we end up with 2 negatives left. And one last time, we have -5 plus 3. And we can write that as 1, 2, 3, 4, 5 negatives and 3 positives, crossing out our 0 pairs or our positives and negatives that cancel each other out, and we still have -2 each time. And mathematically, what we did, we changed 3 minus 5 into 3 plus 5. However, we've got to change that to -5 because we're not adding 5, we're going down 5. And we can switch that around by putting the -5 first and then plus 3. And some people were wondering why I don't have the parentheses still there. Once I move the negative to the front, then I no longer have this situation. Let me show you. I no longer have this plus and minus situation where they're right together. I just have the -5 and the +3. So I don't have to put parentheses around it because I'm not cleaning anything up. I'm not separating anything out. So you are going to now answer a few questions trying this out, and I will be back with another video.